Genius, we have a test today?
Oh yes, I totally forgot to study. Shoot. Oh. Are you guys ready? Okay. Pencil.
A few moments later.
Bill Nye, the science guy. I'm Heart Bill.
Who
Bill
are
Nye,
you?
the Yahoo! Big science below up. Oh my gosh, I'm so excited you're here. I wasn't expecting you so soon. Helga! Ah! Who's that? It's our visitor. You knew she was coming.
Oh, right.
So, do you have any questions for us?
Well, I mean, I don't really understand Newton's 3 laws of motion.
Newton's 3 laws! Oh my god, favorite! Okay, we'll help you. There we go.
All right, let's take a look at Newton's first law. Newton's first law says an object in motion will remain in motion unless acted upon by an outside force, and an object at rest will remain at rest unless acted on by an outside force.
Any questions?
That doesn't make sense.
Well, let's head over to the demonstration table. All right, now that we're here, we have a glass container, a note card, and a penny. If I add force onto this note card by flicking it, what will happen to the penny?
Obviously, the penny will go with the note card. It's on the note card.
All right, let's find out. As you can see, because there was no force applied to the penny, it went straight down, as where the force was applied to the note card, it went flying towards you. That way.
Oh, I get it. Therefore, there's no force acted upon that object, so it stayed at rest.
Yeah. Back
to the lab. Okay, on to Newton's second law. In his second law, Newton states that force equals mass times acceleration. Okay, this means this means that if I have two objects, this chair and this desk, the chair obviously weighs less than the desk. If I push them with the same amount of force, the chair's acceleration will cause it to go farther. However, if I push it with a greater amount of force on the table will match the chair's acceleration. Does that make sense?
I think I get it. Okay, so what about Newton's third law?
Okay, let's take a look. Newton's third law states that for every action, there is an equal and opposite reaction.
This statement means that in every interaction, there is a pair of forces acting on the two interacting objects. In this clip, because one of the forces was greater, the smaller force had a greater reaction to the interaction.
Okay, understood?
I think I get them.
All right, well, I think it's time for you to go back to class.
What'd you get for 3?
Yeah.
Success!
Okay, and then should I just ignore her?
Yeah.
Okay.
Yeah, that's okay. I'll turn it off.
We're like,
I'm just like, I know.
Hey!
Yahoo! Big science.
Okay.
Laws.
Newton's 3 laws! Oh my gosh, my favorite! How come you knocked my pencil out of my hand? Oh shoot. Okay, what questions do you have?
All right, now that we're here, we have a glass cylinder. That's not what we said that I was going to say. Ah! Oh, bye, Zach! Work! Nailed it!
Oh shit.
I need him. How about now? Okay. As you can see, he's a banana. Okay. No. As you can see. Kaleen sucks.
All around me are familiar faces, worn out places.
Okay, well, I think it's back for you to